We will tell about GIS and remote sensing using in agriculture today to try answering on some of very important questions. The first question, what is the meaning of agriculture? What is the importance of it? What is the data of place to set agriculture using GIS? The third, what is the effect of surface elevation and geology on agriculture using GIS and remote sensing? What is the effect of soil on agriculture using GIS and remote sensing? How the irrigation can be effect on agriculture using GIS and remote sensing? How we can testing irrigation network weakness and strong areas by GIS and remote sensing? What is the effect of water irrigation quality by GIS and remote sensing? How we can using climate modeling with BISM model for crop water requirements by GIS and remote sensing? What is the mainly crops and the spatial distribution analysis in our area? How we can using GIS and remote sensing together for irrigation network design? How we can monitoring and evaluation soil salinity, crop diversity, building urban on farming lands. Allah gave Egypt Nile from the past, from the mountain of Ethiopia. The ancient Egyptian farming documented that on the templates walls and doing more efforts in agriculture because it is his life and be inherited it for us. In firstly, we need to know more about the meaning of agriculture and how the data of place affect on agriculture activities. Before that, what is the data of place and requirements? In our presentation, we will studying agriculture in Egypt. Soha Governorate case study that is placed in Upper Egypt located in south of country. That area is arid zone. This surely effect in crops, water, irrigation, and animals, farmers' habitats. Agriculture is group of process to create a suitable environment for the growth of plants and raising animal, including soil and related operations, irrigation, drainage, crops, fertilization. Agriculture includes all the productive efforts made by human to settle on the earth and improve planet types that desires and satisfy its needs. Our area is located in arid zone, so that is a special case in agriculture, crops, water, irrigation, animals, farmers' habitats. Our area division to 12 district, 3 of this in eastern side, while 9 in western side. Division of area by Nile River in all area farming activities is mainly depending on flooding irrigation by canals network out from Naga Hamadi canals in Shaw, canals A, canals B from south to north with pumping and aspect slope of surface. By digital elevation model, we can studying the effect of surface forms. Our area division two main areas. The first area, Nile River in middle beside that floodplain. That is farming area. Beside that, there was Eocene plateau. In east and west, these mountain areas, not for you. This area we can doing more reclamation for it. in some areas. You can see the difference between elevations in our area from east to west in the Nile, in the floodplain, in the Eocene plateau. I think you see that the low elevations in Nile River. The geology side of our area. Our area is have two mainly geology forms. I think the quaternary deposition is the area of farming and reclamation. You can see that from the map. While the tertiary deposition is specific to reclamation because no having to water in that area and the soil can't be more for agriculture. There was some of surface forms we can observe it and its effect on farming, such as the Eocene plateau in the west and east, caused to narrow or tight the farming area and breadth in other areas that caused to drilling tunnels to passing water to farming lands. There was other forms of surface we can observe it. I think the dangers of sand dunes in this area is very dangerous for soil by mixing sand and clay that is effect on crops growth. In the other side, I think canals filling by sand caused to losses water by sand which absorbing it and that is needing more money to cleaning and decontamination. We can see some of crops can be farming on mountain such as tree and grapes, that is irrigation by pumping water to high level but that needing more money. I think really the soil can be answering on what is the best crop to farming here or where is the best location to farming these crops. I think there was a lot of soils in all over the world. Each of it grows crops, give high productivity. In our case study area, the clay loam or loam texture in good structure and moderate water holding capacity are ideal for wheat cultivation. And in other, the silt clay loam and clay are some of the soil textures that are best for rice farming in North Delta. The sand and silt nice for sugar cane. This is different texture and soils. I think in the map you can see the difference between heavy and medium and light and sand soil in the eastern and western side. What is the water source? We say before Sohagaria irrigating by canals from the Nile River. That is main source of our area. By some of canals, outs and absorbing canals from the Nile. Why that? By pumping. You need for that data for canals, canal length, canal water quantity and location of pumping water and the location of area to irrigated. We can studying our area in strong and weakness areas to know the problems of water in canal and solve it by GIS. You see in the map we are division our area to very high density, medium density, low density, very low density of canals. This technique in GIS depending on the area and containing of canals length, canals number. There was another source of water in our area for irrigation. I think groundwater using to implementation areas in eastern and western plateau or solving water problem, not reach to fill, just studying water quality to choosing the suitable crop for farming by taking samples from wells and make analysis in laboratory by chemical and physical for water to specific the soil and crop to farming. We can monitoring the groundwater levels in different years, in different time, in different location by GIS. Just stop on and bend on data of location. You can see in this map the high level of groundwater in south area and to the next for the north we can see the low level of groundwater that is affected by Nile River at 4 seasons at year. In a spatial analysis case, we can predict the elevation and why the elevation is high and low, low and high by take a samples of well farmers drilling it to know how the groundwater is low and high, high and low. Groundwater quality modeling in GIS. How we can do that? Yes, you can do that by take a samples of wells, samples of water, sample of soil and make analysis for chemicals to know what is the chemical elements of your area. You can see in the map in blue area is so bad water for irrigated. In yellow area you can see the medium water quality. In red that is a good irrigated water. You can suggest by groundwater modeling the causes of why the bad water and medium water and good water in our area, because the farmers absorbing more water from groundwater and recharging again by range water of lands. To reclamation, to to make a reclamation in reclamation areas needing studying for all agriculture elements such as soil, water, climate, and farmers' habits. In our area, we can make a reclamation in 5 areas in the east and west. In the biggest area in the south. Why is that? Because the positions of floodplain is more in this area. You say before we can studying the geology and surface forms. From this studying we can reach two goal. Our goal is reclamation. But there was a problems in this area. Why? I think we don't have a water. To reach the water for this area, we can pumping it from the Nile to the mountain, and that's need more money. The climate elements, I mean temperature, humidity, wind, dew point, the other elements. This was effect on agriculture elements, land, animals, irrigation, crops. In this graph, we can see the high temperature in our area and in low in different months at the year. That is effect on everything in agriculture activities. Here in our area we will apply on GIS model for modeling crop water requirements. I meaning ETO, evapotranspiration, that depending on solar radiation, temperature, actual vapor pressure, saturation vapor pressure, wind, we can enter all data in the model collecting from field. This model depend on latitude, longitude for every area on earth, and climate elements depending on Panama Montes modification formula by FAO. To description more about crop water requirements of our area, we can apply that and make irrigation schedule at the crop age growth. We have a data of climate for our area and enter it to GIS model for temperature, wind, solar radiation, dew point, and in finish we calculate ETO and enter it to GIS to know where is the area in high and medium and low. And in our area the high evapotranspiration in the south area, and directly for the north area is low evapotranspiration, 4.6 I think for every day. In our area there was different crops has a spatial distribution by types. the wheat is more farming crop in all districts. Sugarcane was concentration at the south districts that needing more water to farming, and corn was farming at all district also. If we have a data of crops area and evapotranspiration for every crops in our area, we can doing spatial analysis, distribution and mapping for it, monitoring for it, to know where is the problems and solving. By the data from this mapping GIS, we can see the biggest farming area at south district and the low in north, but the over and more water using in south, not in the north. That's problem. Why? Because in the south area we are farming wheat and sugarcane and clover in high, and in north we are farming wheat in more and corn, but the sugar is high using for water. Just make analysis for geospatial data for your area. In our area, I think the farmers in south taking a water of the north. The farmers in south area take a portion of the farmers in north from canals, from water, from life, I think. The remote sensing and GIS technology using together, I think that is playing important role in our life every day, but that is without field study is nothing. Everything nothing. Why that? Because we are reach to the goal. The goal is more accurate data, and to make a more accurate data you can see the feature in location, you can see the feature in latitude and longitude. We can using GIS and remote sensing together for make irrigation network design depending on data from field for irrigation source, for area study. We can drawing croquis for our area and enter the area limits and the water source located by longitude, latitude. Then we can get aerial photo or high resolution satellite image to calculate the distance between trees and calculate the distance from water irrigation source to our farming area. That is first step for design the network. The agriculture productivity, that is an important thing for every country and all over the world. That is economic and food case. So we can studying in our area for an important crop for human. We chose wheat crop farming in the winter and make a comparison between farming area of wheat through differences here, applying NDVI and LEI. That is the relation between near infrared band and red band in Landsat satellite image. We can see the left side photo have a high productivity for wheat, that is now, while the right photo have radius of high productivity area, because our country doing more projects in irrigation and drainage caused to high productivity. That is a spatial analysis, high spatial analysis for our conclusion. Every channel have water and crop codified, and farmers exceed it, caused two problems in other areas. We can monitoring that through the satellite image and take samples from lands and compare it with apply NDVI. We can see in the map resulting from satellite image classification and analysis in yellow areas within mid time of age, in green in old age, in red color the other crops. We can doing something more about this. In soil, we can studying soil salinity and the comparison between some years. We can apply some of indices for soil such as SAVI, SI, SNDI. That is relation between bands visible and not visible, such as near infrared and thermal. We can doing that, but without field study in soil salinity, everything is nothing yet. In this map, right and left, you can see the difference between area of soil salinity, and that is applying by SI and NDSI and SAVI, and the comparison between it is show the very high salinity in the past. In right side photo, that is because what? Because the country making such as projects and support the farmers to doing network for irrigation and drainage. We can apply NDBI index for monitoring building on lands. That is relation between short infrared and near infrared. Building on farmland is loses more resource of human, is lose the life. We can monitoring that and evaluate it. You can see the difference between these photos. The difference between 2 years, the land farm is concentration of building that is more dangerous. In the end, I'm happy to meet you today, scientists.